Welcome back to the deep dive. Today we're looking at a single piece of hardware that aims to solve a huge headache in facility management.
A very common headache. The constant battle for more sensor ports.
Exactly. We're doing a deep dive on the NTI E-DI16DOR16-V2-D expander.
And our mission here is to really understand how it changes the game for, scaling up an environment monitoring system like NTI's E2D or E16D. It's really an efficiency engine.
Okay, so let's unpack that. The basic challenge is just port scarcity. You have a few expensive RJ45 sensor ports, but dozens of things you need to watch.
Doors, smoke detectors, water leaks, you name it.
And this little box turns one of those ports into something much, much bigger.
It's a massive multiplier.
Yeah.
You connect this thing with a single CT5 cable, and you instantly get 16 more digital inputs for sensors.
And not just inputs.
Right. And you get 16 digital relay outputs for control. So you're turning one connection point into 32 endpoints.
That completely changes your monitoring landscape. Let's start with the inputs. What is the V2D actually reading?
So the input side is built for, I'd say, resilience. You get 16 screw terminal pairs for any standard dry contact device.
So your basic stuff. Door switches, simple alarms.
Exactly. Anything that gives you a simple open or close signal, that's your foundation.
In the specs, I saw they're described as potential free. Can you break that down for us?
Sure. Potential free just means the inputs themselves don't supply any power. They're passive.
Ah, okay.
They're just listening for a voltage state from whatever you connect. And that makes them super flexible. They can handle 0 to plus 36 VDC, and they're surge protected.
Which is critical. And here's a surprising little detail I found. One of those inputs is very specific.
That's right. One dedicated pair is a tachometer input.
For what? Measuring fan speed?
Fan speed, pump speed, anything that rotates. It can measure from 0 up to 255 hertz. It's a really smart inclusion.
And the physical reach here is pretty wild. We're talking cable runs up to 500 feet.
500 feet, yeah. About 152 meters. Using standard CT5 cable. So you can cover a huge area like a massive data center from one central point.
Okay, so we get how it reads data. What about the control side, the O in I/O?
The output side uses what's called a normally open SPST relay design.
SPST, so single pole, single throw. Basically a simple on-off switch.
A simple electronic switch, exactly. The NTI system can use it to turn up to 16 external devices on or off.
Now, I did see the rating is pretty low, 125 volts AC at half an amp, or 30 volts DC at 1 amp. Is that enough to be useful?
That's a great question. It's not designed to switch, a heavy industrial motor directly.
Yeah.
It's really for signaling.
Okay, so it's a trigger.
It's a command signal. It can turn on an indicator light, or more commonly, it can trigger a separate high-power relay that then handles the heavy load.
And that brings us to what might be the most crucial detail here, the galvanic isolation. Why is that so important?
This is the key engineering feature.
Yeah.
The outputs are galvanically isolated to 1 kilovolt, 1 kV.
So no direct electrical connection between the two sides.
No, it's an air gap, essentially. That means if there's a huge power surge on the device you're controlling out in the field,
like a lightning strike nearby or something.
right, that high voltage is stopped dead. It can't backfeed and destroy your very expensive, very sensitive monitoring system. It's a firewall.
A safety firewall. That makes perfect sense. So you've got protection, reach, and it maximizes your hardware. It's also TAA compliant and can be mounted on a desktop or a DAN rail.
Very flexible.
And the price we saw for this specific model, the V2D with that 1 kV isolation, was around $325. There are cheaper versions, but they might not have that critical protection.
And that's really the value proposition. You are maximizing your reach and your control points, but you're doing it while ensuring your core system's integrity. It's all about scaling safely.
So if 16 points of monitoring and control can be added securely through just one RJ45 port, it leaves you with a question to think about for your own setup. What are the genuine limits of environment monitoring expansion in a modern data center? Maybe they're further out than you think.